Okay, everybody, so this is Precalc A test review video, and I'm probably not going to go through every single problem, but I'll at least give you some stuff for so make sure you understand some of the problems that are going to be on here, okay? And this one's for calculator specific. As you know, we have two different ones, calculator one and this. So here are some of the example problems. You guys can just kind of search through your notes for it. I know I gave you the topics, so here are some of the things that you're going to definitely need to know how to do. So absolute value 3x minus 5, say equals 8, or the absolute value of, say, like negative 2x plus 7 is less than 16. Stuff like that. So absolute values with either an equation or an inequality. And just a quick little reminder again, you have to treat these 3x minus 5 equals 8 and 3x minus 5 equals negative 8, and solve both of those ones because it could be 8 or negative 8 underneath here. Let me focus that in a little bit. Just look at the screen. Over here, I got to write negative 2x plus 7 is less than 16. And I got to write negative 2x plus 7 is greater than negative 16. So again, this one's going to have two actual answers. This one's going to have a range of answers. And remember, know how to be able to do all those inequalities here. Number 2, I gave you example problems on here, but make sure you can do this. Negative 16t squared plus vt plus h sub 0. And really, it's just about knowing what the velocity was and what the initial height was, and then using your graphing calculator. And you saw before on that, we need to know how, say this is the parabola, we need to know how high it goes, when it might hit the ground, when it's either over or under a certain height, which means you're just going to put that height into your y2 and do some intersections there. So that kind of a problem. What else we got here? Let's say I had this, y equals negative 2x cubed plus 7x squared minus 5x plus 4, and I want to know where the zeros are of this function. Don't try and factor that. That's really scary. This is a cubic, right? Something looks like this. So if it happens to hit 3 times, which it could, or hit 1 time, or hit 2 times, whatever, you're just trying to find the x-axis, because x-axis is when y is 0, and that's what that means. So just go ahead and use the 0 function in your calculator, or put y2 as being 0, and find those intersection points. So those types of things. You guys know I have these 3 acronyms, DIMS, DAP, and ATD. Those are all on my wall. We've talked about them in class before. DIMS stands for does it make sense, which is what you need to ask yourself when you have answers. Are they logical, reasonable, comprehensionable, based on the topics that we're dealing with? DAAP stands for draw an accurate picture. So when you draw something, does it actually look like what it's supposed to look like? And ATD, attention to detail. Did you put commas in the right places, brackets or parentheses? Did you raise it to a positive power, negative power? You know, like if you entered this into your graphing calculator, did you remember to make the velocity positive if it was opening up, make the velocity negative if it was opening down, or sorry, if it was being thrown down? So just making sure that you pay attention to all those little detail things. Okay, 5, something like this. X to the third, y to the negative 4, z to the 7th, over x squared, y to the negative 5, z to the negative 2, and saying, hey, can I simplify this exponential, this rational expression with exponents? So yes, this final answer, x3 over x2 would be an x on top. These 4 go down, those 5 go up, and leaves a y on top. There's 7 of them are here, and 2 of them, when they go through the floorboards or the fraction bar, they become positive. So that'd be a z to the 9th. That would all be over 1. if you had letters left downstairs, you could do them, but this one doesn't have it. So if you want to, you can just write that as your final answer. So you guys remember this one? So let's say we had a rectangle that was 3x long and x high, and we had a semicircle up on top, and I gave you the area of this whole thing. Remember, we definitely want to find the solutions to this by way of graphing. So you need to know your basic rectangle formula for area, which is length times width, and for a semicircle, which would be pi r squared is for a circle. So cutting in half if it was a semicircle. My apologies. There you go. That's what that looks like right there. So again, just being able to do the relationship between those two things and then putting them in your calculator correctly. Okay, so we'll go here. What are some other things that are going to be on your test? So let's say that I had this, y equals x minus 5 times 2x plus 7 times x minus, let's do x plus 3. And I said, hey, I want you to find all of the solutions to this equation when y equals 0. Awesome. So that's like saying that the zeros are the function of where it crosses the x-axis. So I would know that this is a cubic function because it has an x times an x times an x. And I would have 3 solutions. So one of them would be at 5. This one would be at negative 7 halves, or negative 3.5, and this one would be at negative 3. So again, it's whatever makes those things zeros. And what was it? Like example number 7. So what are some other things that you guys would see? You know, right, if I had this, parentheses 3 comma 16 bracket, this is considered interval notation, and how would I write that out as an algebraic inequality? I would write 3 is less than x is less than or equal to 16. And how would I write that out graphically? That would be a 3 with an open circle and a 16 with a closed circle, so something like that. No, and I know I'm going fast on some of these things, but hopefully this is just quick little review stuff. So that if I had 2 points, 4 comma 2 and negative 6 comma 8, and these were both endpoints of the diameter of a circle. So if I did that for 2, 1, 2, 3, 4, 1, 2, and negative 6, 8, 1, 2, 3, 4, 5, 6, negative 6, and 8 way up there. And if I said that those were the endpoints of the diameter of a circle, and I go, hey, what's the equation of that circle? Well, you know the equation of the circle is based on the center point. So I need to find the center point. So the center point is the midpoint between these things. So 4 and negative 6 is negative 2 over 2 is negative 1, and then 2 and 8 is 10, divided by 2 is 5. So the midpoint has to be at negative 1, 5, and as soon as I get that, I look at my picture and I go, hey, that kind of looks like it's negative 1, 5. So that means we go x plus 1 quantity squared plus y minus 5 quantity squared equals, and then whatever this is the radius squared. Well, the radius is the distance from the midpoint to a point over there. So then I'm going to go ahead and take these two and find the distance formula there. So the distance formula says find the difference in the x's, or the distance between the x's, which is 5, and square them, that's 25. And the difference in the y's, and that's 3, and squared is 9. And then, so the radius is the square root of 34, what you get when you add those together. But the formula has the radius squared, so you can just write 34. Okay, so quickly, again, given 2 points, we did a bunch of stuff right there, right? We did distance formula, we did midpoint formula, and we did equation of a circle. Equation of a circle. Okay, so being able to do something like that, being able to factor, so like if I said this, let's do number 10, x squared minus 7x plus 10 equals 0, and being able to solve that by factoring. So you would do something like this, and you go, hey, factors of 10 are 1 and 10 and 2 and 5, and I need them to add up to 7. So that'd be an x minus 2 and an x minus 5, which means my solutions are 2 and positive 5. Okay, so solving by factoring, definitely one of the things that we needed to be able to do. A lot of stuff with lines. So if I had 6 comma negative 8 and 4 comma 2, let's make that negative 4 comma 2. And I said find the equation of a line that goes through here. Well, the first thing I'd have to do is find the slope. Find the slope of this. So 2 minus negative 8. 2 minus negative 8 is 10. And the negative 4 minus 6 is negative 10. So the slope of this line is negative 1. So then I'd write y equals negative 1x plus b. And I'm going to go ahead and pick this one and shove it in there as a point. So 2 equals negative 4 plus b. 2 equals 4 plus b. b equals negative 2 when I subtract the 4 to the other side. So my equation is y equals negative 1x, whether or not you put the 1, I don't really care, minus 2. Oh, I'm so sorry. Look at that. I did it again. Sorry, my monitor's over there, so I can't necessarily see what it is. So hopefully that followed as you went through there. There's your line. Now, again, it doesn't take me but a few seconds to be able to do this. 6, negative 8, 1, 2, 3, 4, 5, 6, negative 8, that's like way down here, and negative 4, 2, negative 4, and 2, and there's my line, right? There's my line. And that's just my quick sketch of my line. So I ask you, does that make sense? So a negative slope, about a 45-degree angle, because remember, a slope of 1 or negative 1 is 45 degrees. So that looks pretty darn good, and then the y-intercept's negative 2. So dang, I feel really good about that answer. So again, a couple of things here. One, that's to find the equation of a line given 2 points. I found it in slope-intercept form. We also had to find lines that are parallel or perpendicular to a given line. So remember these facts. Parallel lines have the same slope, and perpendicular lines have opposite reciprocals. Okay, so just give you, for instance, let's say my original line had a slope of 2/3, then the parallel line would have a slope of 2/3, and the perpendicular line would have a slope of negative 3/2. Okay. So what else we got? Let's go to example number 12. What are some of the things that we have here? Oh, some basic stuff like 4 times 2x minus 3 plus 6 x minus 7 equals negative 2 times 3x plus 5. So just being able to solve a basic linear equation here. Remember, we're going to remove all parentheses, right? We're going to do that by distributing into all these things. Then we're going to combine like terms on the left side, combine like terms on the right side, and then move stuff around. Remember that whenever you solve any of these things, that you can take this handy dandy little calculator and store the values in there. So like if my answer was 1.56, like that was my answer. Let me clear it all out. I would do 1.56. I'm going to store it in x, and then type it in to whatever my original equation was. Just to make sure we're clear on this, I just made that up. That answer is not 1.56 in any way on that last problem. Just showing you again. Store right here, x right there. That's what I would use to be able to check. So what are some other things? Oh, imaginary numbers. So let's say I had x squared plus 6x plus 16 equals 0. I'm like, hey, I want to find the solutions to that. And you're like, oh, it's a graphing calculator one. I can do this. So I just go to my graphing calculator and I clear these things. And I'm like, x squared plus 6x plus 16. Graph. Oh, crap, it doesn't touch. So whenever you know it doesn't touch the x-axis, that means it has to have imaginary solutions. Yay, imaginary. Okay, so then you have two options, right? You can either complete the square or you can use the quadratic formula. I'm going to go ahead and complete the square. So x squared plus 6x equals negative 16. Move that over. Always take half my linear term and put it in the little square box. 3, and then I square that. So that's going to be a plus 9, and that's going to be a plus 9. So then I get x plus 3 quantity squared, because that always factors perfectly into x and whatever's in your box. Equals, looks like I got a negative 7 over there. Root it, x plus 3 equals plus or minus I root 7. Because a negative underneath a radical is equivalent to an imaginary number on the outside of the radical. Final answer is x equals negative 3 plus I root 7 and negative 3 minus I root 7. So being able to do that, we're going to be able to solve them that way. I also got completing the square in there too, so that's pretty good for you. Good deal. So this one, 14. So this is a long one, and you can watch the other video on this. But let's say I wanted to find the equation of a line tangent to a parabola. Okay, that's using the thing called the difference quotient. So let's say I get a line or a parabola y equals 3x squared minus 6x plus 7, and when x is equal to 4. Okay, so again, you have to use this formula, f of x plus h minus f of x all over h as h approaches 0. That's called the difference quotient, and there is a video on the Google Classroom. You need to watch that video. It's pretty long, but it's detailed to be able to get that. Okay, and that's going to be on it's worth like 4 points, where a lot of these are only worth 1 or 2 points. So it might be worth it for you guys to actually take your time to watch that video. Plug it in there. Good deal. So what are some of the other things that you guys need to know how to do? Let me double check some of the stuff that I have on here. You need to 15 add, subtract, multiply, divide complex numbers. So I'll give you a quick little rundown on that. So maybe I've got 3 plus 4i over 2 minus 6i, and I'm trying to do this division. And we said one of the rules is we can't have imaginary numbers on the bottom. So we said to fix that, we would multiply top and bottom of the top of the fraction, bottom of the fraction by the same number, but that these numbers would be what we call complex conjugates, because they're going to wipe out the imaginary parts. So you can see it, 2 times 2 is 4. Negative 12i, positive 12i go poof. So I get 4. And then negative 6i times 6i is negative 36i squared, which becomes plus 36, which means my new denominator is 40. On the top, 2 times 3 is 6. 8i and 18i is plus 26i. And then 4i times 6i is 24i squared, which is minus 24. So I get negative 18 plus 26i. And then those can reduce. So that reduces to 9 and 20 and 13. And that's all I can reduce. So negative 9/20 plus 13/20 I. That's the final answer there. Okay. You have to be able to do this stuff. So like say I have this 5 times x plus 3 quantity squared minus 7 equals 16. And solve that equation, preferably without a calculator. You can do it by hand. We'll see what we get here. So we know we're trying to isolate the x, so we got to remove stuff. So I had plus 7, I had plus 7. 5 times x plus 3, quantity squared, equals 23. Divide by 5, divide by 5. I get x plus 3, quantity squared, equals, I'm going to go ahead and leave that as 23/5. It'll be good for you if you're doing some fraction-y stuff. So square root here, so I get x plus 3 equals plus or minus the square root of 23/5. X equals -3 plus the square root of 23/5 and -3 minus the square root of 23/5. And at this point in this course, I'm okay with you leaving those in radical form, even with the radical on the bottom, because I didn't take the time yet to review simplifying those radicals. So if that shows up, you can leave them like that, and it'll be totally fine on the problem. Okay, 4 comma 2 and 6 comma -3 and -8 comma -7. So one of the things I would ask with this is, can you find the perimeter of this triangle and then tell me, is it scalene? Which means all 3 sides are different lengths. Is it isosceles? Which means at least 2 of the sides are the same length, or is it equilateral? Which is all 3 sides the same length. So again, with this, you just have to be able to do the distance formula. So I'd probably plot those 3 points and kind of at least get a picture of it before I start doing the distance formula. That way I'd know when these things come out, if they actually match up picture-wise based on the stuff. So definitely be able to do that. Inequalities, yes. I feel like I've covered a lot of things, and I don't want to overwhelm you right now. So remember, you can use notes. Yes, you can use notes that you get. You're giving you 150 minutes. Man, some of you are going to finish in like 40 because you know your stuff. But I give you 150 minutes of it, so 2.5 hours worth of time. It's got to be done by Sunday night. And remember, if you... This is going to be the hard thing. You can't come back to problems. So if you log out to come back and work on it again, a problem that you had before that you were working on, you can't try that problem anymore. Okay? So you got to make sure when you log out, if you're going to try it again, if you're not going to do this in one constant time stretch, if you log out, you've got to make sure that you've finished all those problems. Okay? And then hopefully, for those of you who are paying attention and you've stuck with it all this time, I have a bonus for you, but you gotta be still listening, which is awesome. So let's go orange octopus. Okay, so the first 5 people that show me orange octopus in an email, that send that to me, I'm gonna give you some extra credit for this test. However, if you're the only one that sends it to me, because you're the only one that paid attention this long, then I'm going to give you like 10 points. Okay, so don't just call up your other friends and give them the answer. See if it can just be you. See if that's the case. So again, good luck, and we will talk to you later. See ya.